video, we are going to study colligative properties from topic solution. First, I define colligative properties. Colligative properties are physical properties of solution that depends only on number of solute particles in solution and not on nature of solute particle in solution. Colligative properties are physical properties of solution that depends only on number of solute particles in solution and not on nature of solute particle in solution. These are four properties. Number 1, vapor pressure lowering, vapor pressure lowering. Second, boiling point elevation. Second is boiling point elevation. Third, freezing point depression. Freezing point depression. And fourth, osmotic pressure. Osmotic pressure. Now in detail we are going to study vapor pressure lowering. Now first colligative property, lowering in vapor pressure. First we see only vapor pressure for liquid. Last year we studied in detail. At liquid surface there are some liquid molecules, but due to increase in kinetic energy some are converted into its vapor state, and again due to collision they are come to liquid state. Vaporization and condensation goes simultaneously. At equilibrium, rate of vaporization becomes exactly equal to rate of condensation. The vapor pressure is applied on the surface. Pressure applied on the surface due to vapor on liquid surface is known as vapor pressure. Now we consider one experiment where we take two closed containers. In first container there is only pure solvent. Pure solvent. Here vapors include vapors of its liquid and pressure exerted is shown in this apparatus. Suppose we consider this as P10. P10 is vapor pressure of pure solvent. Now consider another closed container in which non-volatile solute is added. These are non-volatile solute molecules, non-volatile and non-ionizable. Non-volatile solute is added. When this solute is added and solution is formed, at the surface of solution, liquid molecules are present with solute molecules also. Solvent molecules are there, solute molecules are there. Solute is non-volatile and due to this, vapor of this surface of liquid or solution contained or contributed by only solvent molecule. Vapor present on the surface of solution is contributed only by solvent molecule and not solute molecule, because solute are non-volatile in nature, and therefore vapor pressure here is only contributed by solvent molecule, and this is comparatively less than pure solvent, which is here we can indicate by a pattern. Suppose P1 is vapor pressure of solution containing non-volatile solute. Solvent containing non-volatile solute. Here P1 is less than P10. P1 is less than P10 due to addition of non-volatile solute in solution. We can write P10 minus P1. This is given by delta P, and here delta P is lowering in vapor pressure. Delta P is lowering in vapor pressure. Which is given by delta P is equal to P10 minus P1. This is lowering in vapor pressure. Now I discuss Raoult's law for solution of non-volatile solute, and for this we first see one video.
When a solvent is kept in the open, then the solvent molecules evaporate from the surface of the liquid, and an equilibrium is established between the solvent molecules in vapor phase and in liquid phase. The vapors above the liquid solvent create a pressure known as vapor pressure of the solvent. It can be recorded by using a pressure gauge as shown in the animation. When solid solute particles are added to the solvent, then evaporation of this solution takes place. The vapor phase again consists of vapors of the solvent, that is, of water, because the solute is non-volatile. However, the vapor pressure of the solution is found to be less than that of the pure solvent. This occurs because the non-volatile solute molecules occupy certain surface area as shown in the animation. As a result, lesser number of solvent molecules will escape into vapors. Raoult quantitatively studied the relationship between lowering of vapor pressure of solvent on addition of a non-volatile solute and gave Raoult's law, according to which the partial vapor pressure of a volatile component in the solution is directly proportional to the mole fraction in it.
Now, once again we come to the point Raoult's law. According to this law, vapor pressure of solvent in solution is equal to vapor pressure of pure solvent into its mole fraction. X1 is mole fraction of solvent molecule. If we plot the graph of vapor pressure against the mole fraction, suppose on x-axis we take mole fraction from 0 to 1, 0 to 1, and vapor pressure along y-axis, then we get a straight line. We also know that sum of mole fraction of each component present in solution is 1. Find value of x1 from this, we get 1 minus x2. Put this value in this equation. P1 is equal to P10 1 minus x2. P1 is equal to P10 minus P10 x2. पॉझिटिव्ह करूयात ही टर्म, आपल्याला असं मिळेल P1 प्लस P10 x2 इक्वल टू P10. थोडंसं रिअरेंज करूयात. P10 इज इक्वल टू P1 प्लस P10 x2. We can write P10 minus ही टर्म इकडे आणली मी, P1 is equal to P10 x2. From this we can write P10 minus P1 is nothing but delta P. In last point we define it. It is difference between vapor pressure of pure solvent and solvent in solution, which is equal to now P10 x2. Here P10 is constant for some solution. Particular solution म्हणजे जे तुम्ही सॉल्व्हंट कन्सिडर केलाय त्याच्यासाठी P10 हे कॉन्स्टंट असेल. आणि याच्यावरून आपल्याला असं लक्षात येतं की लोअरिंग इन व्हेपर प्रेशर इज प्रोपोर्शनल टू x2. x2 is nothing but it is mole fraction of solute. It is nothing but number of solute. That means lowering in vapor pressure depends on number of solute, and from this we can say that lowering in vapor pressure is a colligative property. Now I am going to discuss point relative lowering of vapor pressure. Relative lowering of vapor pressure is ratio of lowering in vapor pressure to vapor pressure of pure solvent. From this we can write delta P divided by P10 is equal to delta P ची व्हॅल्यू आपण इथे पुट केली P10 minus P1 divided by P10. आपण राउल्स लॉच्या पॉइंट मध्ये असं बघितलेलं आहे डेल्टा P is equal to P10 x2. From this we can write delta P divided by P10 is equal to x2, and this becomes equal to P10 minus P1 divided by P10. And from this it is shown that lowering in vapor pressure is also a colligative property, and relative lowering in vapor pressure also a colligative property because it depends only on solute particles. Now next point is molar mass of solute from relative lowering in vapor pressure. आपण relative in lowering in vapor pressure पासून आपण मोलर मास सोल्यूटचा काढू शकतो. कसं ते बघा, आपण इथे डिराइव्ह करायचं आहे. लास्ट पॉइंट मध्ये आपण हे शिकलो, relative lowering in vapor pressure is equal to x2. That is delta P divided by P10 is equal to x2. आपण याला इक्वेशन 1 समजूया. आता x2 ची व्हॅल्यू आपल्याला काढायला हवी. पहिल्यांदा x2 is equal to x2 is mole fraction. It is nothing but ratio of number of moles of that component to total number of moles of each component present in solution. म्हणून आपल्याला असं मिळेल x2 is equal to n2 divided by n1 plus n2. Here n2 is number of moles of solute particles, n1 number of moles of solvent. For dilute solution, जर सोल्युशन डायल्यूट असेल म्हणजेच आपण सोल्यूट फार कमी प्रमाणात ऍड केलं असेल तर त्याचे नंबर ऑफ मोल्स हे निश्चितच कमी असणार आहे. n2 is very less than n1. आणि असं असेल तर आपल्याला n1 plus n2 ही व्हॅल्यू नियरली इक्वल टू n1 मिळेल. Now from this we can write x2 is equal to n2 divided by n1. आपण याच्या ऐवजी फक्त n1 इतकीच व्हॅल्यू पुट केलेली आहे. x2 is equal to n2 divided by n1. आता काही आपण याचे जे मोलर मास किंवा गिवन मास असेल याचे सगळ्याचे काही अझम्पशन्स इथं लिहूयात आणि परत या डेरिव्हेशन कडे येऊयात. M1 is molar mass for solvent. Whenever there is 1, it is for solvent. Whenever there is 2, it is for solute. जर समजा हे सोल्युशन आपण प्रिपेअर केलेले आहे बाय डिझॉल्विंग W2 अमाउंट ऑफ, दिस इज अमाउंट ऑफ सोल्यूट किंवा मास ऑफ सोल्यूट, सॉरी मास ऑफ, बरोबर आहे, हे सोल्यूट विच इज डिझॉल्व्ड इन W2 gram of solvent. This is mass of solvent. N1 and N2 are number of moles for solvent respectively. From these four values we can calculate value of N1 and N2. What are that values? N1 equal to W1 divided by M1 and N2 equal to W2 divided by M2. Okay, now these values we put in equation number 2. We get काय मिळेल आपल्याला x2 equal to W2 M2 divided by W1 M1. आता ही व्हॅल्यू आपण इक्वेशन 1 मध्ये घालणार आहोत. डेल्टा P डिवाइडेड बाय P10 इज इक्वल टू, इथं थोडंसं सिम्प्लिफाय होईल, डिवाइडेड बाय एनीथिंग इज गेट मल्टिप्लाइड, W2 M1 divided by W1 M2. हे थोडंसं अजून आपण स्प्लिट करून लिहू शकतो. डेल्टा P डिवाइडेड बाय P10 विच इज इक्वल टू P10 मायनस P1 डिवाइडेड बाय P10 इज इक्वल टू, आता आलेली टर्म W2 M1 divided by W1 M2. And from this formula, by knowing values of vapor pressure of pure solvent, vapor pressure of solvent in solution, mass of solute, mass of solvent, molar mass of solvent, we can calculate M2, that is molar mass of solute.